Hello, ladies and gentlemen. Today we're going to be taking a look at another system of logs called the natural log. So for this, you're going to need your notes, something to write with, as well as a calculator. So we've been working with logs, regular log logs, that is. These common logs, base 10, log button, all of these things are familiar to you. But now it's time to take a look at natural logs. These are logs that have a base of e. So rather than write log with a base of e, like this first part shows, we can think about that in terms of a whole other system of logs called the natural log, abbreviated with ln, and there's a little base of e that's assumed to always be there. So rather than write log with a base of e, we'll be looking at things with an ln because that's the system of logs associated with a base of e. Okay, let's get this example in your notes. So the ln of 6, ladies and gentlemen. You have an ln button on your calculator. You can go ahead and type that, ln 6, and see what your calculator tells you. My calculator says 1.79. Remember what this means. Remember what we're asking from the calculator. We're asking the calculator what exponent on e now. Remember there's a little base of e for all natural logs. What exponent on e makes 6? So the calculator says it would be e to the 1.79 makes approximately 6. So that calculator is giving us an exponent that's on an e whenever we type that natural log button. We can work with natural logs and e just like we work with any other base or log. So we can rewrite things in log form. Like this first example you need to get in your notes, we have e to the 4th equals 54.6. If I was going to rewrite that in log form, for this I would write the natural log. Because the base is e, there's a little e that's assumed to be there. If you like writing the little e, you certainly can do that. You will not see that when you hit the natural log on your button or on your calculator, but it's assumed to be there. And then we would write the 54.6 and then the equal sign and then the exponent. Just like working with an log log, we rewrite them in the same way, just using a natural log. So what is this? ln of 12 equals 1.079. What is that in exponent form? Well, remember the base is the e, so it'd be e to 1.079 is about 12. So rewriting back and forth in our two forms doesn't really change much. We're just introducing the idea of another type of log. Now, can we evaluate natural logs, especially without using a calculator when we need to? So for this, I need to write these 4 examples down here. We're going to evaluate the following. We're going to figure out what goes in the little box, and we're going to do that by rewriting it in exponent form first. So if you notice, this first one is ln 1. So remember what that means. There's a little base of e down there. It means e to some power, that's the box, equals 1. What would fill in that box? Once I look at them in exponent form, I might say, what goes in right there that would make that expression turn into a 1? Well, it would be a 0, because anything to the 0 power is 1. So this first one, 0, would be what's missing right there. All right, what about the second one going to my right over here? The ln of e equals something. If you type in the ln of e in a calculator, it's not so bad. Here's why. The little base is e, so we'd have e to the box equals e. What exponent fills in that box to make this equation true here? E to the first power would make e. So when we type in the ln of e, remember we're asking the calculator what power or what exponent on e would give me e. So in that same sort of idea here, when we go to e squared, we're asking the calculator e to some power equals e squared. Hopefully you would look at that and go, well, I'd fill in the box with a 2 because it needs to equal e squared. That's right. If you typed that into your calculator, ln of e squared, your calculator would tell you 2. Anytime we hit the ln button, we're asking what is the power on the e. So if we continue that idea, what do you think would fill in this box over here? What exponent on e makes e to the negative 3? Negative 3 would be the exponent. Remember that natural log button is asking us what power on E makes that value. All right. Continuing on, one more thing to take a look at. We are about to graph natural logs. To graph natural logs, we don't do that much different than we would graph any other log. We're going to need to rewrite what it means, and again use our strategy of plugging in y values and taking a look at what this thing looks like here, okay? So remember when we rewrite what this means, this is like a y. Let's write them in exponent form. Who's the base down here? We'd have e to the y power equals x plus 1. So if we take a look at that and we say, well, now I'm going to need to subtract 1, my equation I'd be using is e to the y power minus a 1 equals x. And now, just like we traditionally would do anytime we're graphing a log and anytime we're going to plug values in here, we would plug in our values in the y column. So my y values, I might use -2, -1, 0, 1, 2, and then I go ahead and evaluate those in my calculator. E to the -2 power, subtract 1, and that value goes in the x part of my table. So for this one, I get 0.86, -0.86, -0.63. For 0, I got 0. For 1, I got 1.72, and 6.39 for 2. These all come from evaluating by plugging in values in the y spot, remember, and filling in the x. So if we make a little picture of what this guy looks like here, over -0.86 down 2, over 0.63 down 1, 0, 0, 1.72 up 1, and over 6 and a little bit more up 2. There's my graph. Okay, he has the same general shape as all the other log graphs. Now, if we were going to describe the domain, range, and asymptote here, domain, range, asymptote, let's start with that asymptote. Do you see where it lines are kind of becomes a little straight here, approaches this line, levels off. Looks like we're looking at that x equals -1 line. So my asymptote is x equals -1. Remember, we can always see that asymptote, back end of our equation. Okay, right there, that's our asymptote. Now, domain and range, remember we placed the -2, -1, 0, 1, 2 into the y column. So my range, my y values are all reals. And then my domain, my x values, I need to describe them based on that asymptote. So it looks like this whole graph, my x values are going to stay to the right of that asymptote, so my x is greater than -1. So whether we're working with natural logs or graphing natural logs, the same rules apply to natural logs that apply to regular traditional log logs, okay? So keep that in mind. I want to thank you for taking good notes, and we'll continue on our journey with logarithms.